Right, so I've been looking at some videos on YouTube about Svelte 5 runes, and it took me kind of a while to get what they're really doing under the hood. I was familiar with the idea of signals, but I didn't really fully get how the reactivity system worked. And so I spent the last few weeks dabbling a little bit in how this new version of Svelte 5 runes work and how signals work, really, so I can understand how to build applications using signals. But I noticed a lot of videos didn't really go into that much depth. Sometimes I felt like some videos were too shallow and other times too deep. So I wanted to make one that sort of gave an idea of how signals work in an easy to understand way. And to do that, we'll actually be building our own kind of mini rudimentary signal framework. But first, I will kind of go over how Svelte 4 works. So this is Svelte 4. So in Svelte 4, we're using stores. If you're not familiar with the older version of Svelte, you can probably skip this part. But I just want to give some context of the history of how it's different. So in Svelte 4, we were using compile time reactivity. And so what that means is I will show you. So here I'm setting a x to 3, as you can see. Now, if I'll write this out and then I'll explain it actually. Y plus 10. Okay, what's going on here? Oops, y. So what's going on here? So we're declaring x is equal to 3. We're declaring that y is a variable. And then we're setting this reactivity block. So this $ says I'm going to make this block reactive. And the way that this works is by compile time reactivity. So what will happen is the compiler will look inside this block. It'll say, oh, hey, there's a $. I need to look in here. And the Svelte compiler will look through it and find any instances of reactive variables. And then it will automatically subscribe to a store, which essentially will say anytime this changes, that changes. So I'll explain that in a little bit more detail. Okay, let's create a button that when you click it, it increments x. So increment. Okay, so as you can see, this works. And even though we're displaying y, what's happening in the background is Svelte is saying, okay, there's a change in x here. So notify all things that are subscribing to the x change, if anything is changed, that something has changed. And here there's a block that we said was reactive, and there's a dependency of x in there. So it's saying, okay, this block needs to rerun because this block depends on x. And this is all done via the compiler. I mean, if you look at the output of the JavaScript, which I won't go into, but if you want, you can kind of reverse engineer this and see how things like, are invalidated and then rerun and all that. But I'm not going to go too into the weeds here, just a little bit into the weeds. Anyway, the problem with this though is that because it's at compile time, it's literally looking at the shallow level of like almost visually. It's almost a visual thing. What's in this block? What can I see in this block? And you can see an x here. Now, if I were to create a function, get x, which would literally just return x, and I put get x here, it would work at the beginning because it would run once. But this block, when it looks, it says, get x. Well, that's a function and it's being called. There's no reactive variable here. And so this actually doesn't have any kind of reactive dependencies. And so when you increment it, nothing happens. I mean, x is being incremented, like we can see here. I'll put x there as well. So you can see x is being incremented, but this is not being run because this is shallowly reactive because it's compile time reactivity. But this is basically how stores work. In the components, you essentially have the compiler looks visually, or lexically, you could say, at all of the different variables and reactive blocks, and then uh, basically wires up the reactivity system during the compilation phase. Whereas signals do something different. So signals work in the during runtime. And so to explain this, what I'll do is we'll build a little bit of a reactive signal system here. So, and you'll see how simple it is. I like, one of the things I like to do is just sort of explain things in a way where they seem simple, because the truth is it is simple. So I'm going to put reactions here, and then let's have a value. Okay, so what you're seeing here is in basic, almost went TypeScript there. Let's see. You know what? Yeah, let's leave it like that. Keep it simple. Right, so let's have a getter on here. So when we get, we're going to simply return the value. And then when we set new value, and then we're going to put value equals new value. So that's what it is for now, and we can actually ignore this. So this is a really simple, actually, is this, can I use get and set here? Is it going to be mad at me? It might be mad. Let's just do get value and set value. So if I create a signal, age equals create signal 30. I think I'm 31. I'm not 100% sure. And then a console.log. Let's say age.get value. Oop. 31. There it is. This is a bit delayed. So as you can see, this is very simple. It's not a signal yet. It's just a shell of a signal. Now, here's what's going to happen. This list of reactions will basically contain a list of all the times, that's like a history of the times that it's been accessed in a way. So that's essentially kind of how signals work. If I'm a value and someone is accessing me, I say, oh, who's accessing me? You're accessing me, I'll record you, and then the next time that I change, I'm gonna call you back. So let's build that out. So we're not just getting the value here. That's the difference. We're actually appending a reactive function to this list of reactions. Actually, you know what? I'll put this outside here. Why did I put value there? It's kind of useless. So, so now what we can do is we can create an effect function. So in Svelte 5, there's these things called roots, which kind of hold all the different effects within that root. But I'm just going to do a simpler version to get the general gist. So if we have an effect, basically what that's saying is this is the kind of function that we want to be passing to the reaction. So yeah, I'll give an example. So what will happen is an effect will essentially take how do we do this? I'm kind of doing this on the spot a little bit. So an effect will take a value? No, it'll take a callback. So it'll take some kind of function, right? And then, oh yeah, this is how it works. So there will be essentially let's say, let current effect equals. Okay. So what it'll do is it'll say, okay, we're starting a new effect. So current effect equals this function. And now we're going to call the function. And then what's going to happen is when the signal, so this function is going to be called in this global variable here. I'll put it at the top just so it's more globally. So this current effect will say, oh, the moment that we retrieve the value from a signal, that signal will be able to tell, oh, which effect is calling this? Well, it's current effect, because that's what was set here, right? So then we'll say, okay, rx.push current effect, and then we'll return the value. And now what you'll see here is this will, okay, actually let me actually create an effect here. So let's wrap this in an effect. Is that right? Did I do this right? There we go. Okay, and you might have seen it there. I'll do it again. So this is actually logged. Will it compile? Okay, maybe not. Anyway, but so we're creating this effect. We're setting this global variable to the function being passed in here, and then we're calling it. And when we call it, this whole function is being pushed into the signals list of reactive dependencies, or rather the opposite, effects. And what that means is that we can say, okay, when we set the value, what do we want to do here? Now we want to update all our effects. So what we'll do is we'll basically go rx dot every, no, I'm just, here, I like to do it this way nowadays, for const reaction, reaction of rx, reaction. Okay, so now we're setting it, and then every time we make a change, it's calling all the reactions. So effect, let's make this a little bit more pretty. There we go, 31. Okay, so what's going to happen now when I say age.setValue 3? New value is not defined. Oh, new val. There we go. So it goes, wait for it. All right. 40. I don't really know. Did I do something? Did I do something silly here? Did I? There must be some sort of recursive issue here. Oh, yeah, that's I did something there. Wait. Probably my computer memory is going like this right now. Yeah, this is, I can't be tracking things, so I have to say if current effect, and then here we'll set current effect equals null, or rather undefined. And then when we're triggering reactions here, we should probably pause our current effect. So let's say let old effect equals current effect equals null, and then after the reaction, current effect equals old effect. I think that might work. I'm not 100% sure, but I also might have just like broke. I'm surprised this is still responsive. Let's refresh this. Okay. There we go. Oh, it works. Great. So the reason there is because I was setting the value, and then when you set the value, it calls the function, but when it calls the function, it gets the value, and then when it gets the value, it sets the new reaction, so on and so forth. But this should work. I'm not saying this is bulletproof. I'm just trying to get the concept across, so you probably might have spot a few things in here that probably shouldn't do. But in any case, so we have these effects, and then the effects are uh, reactive to the functions which they have called. Now, this is a really important part. So the important part here is that this effect won't be reactive to everything in the function, because there's no way that at compile time you can know. Like, you might have some forking going on where if something is set to something else, you might retrieve a value somewhere else. It's not going to be reactive to that value. The only times that signals are reactive is when they're reactive is from the functions, or sorry, from the variables that they're calling, the signals, the values of the signals that they're retrieving when they're called, like when they're actually called, not hypothetically when they might be called, but when they're actually called. Because the first time the effect is run, that's when it sets up these reactions, right? So the first time I call effect, well, I'm getting the get value of age, and then that's setting up a reaction here. Now here, I'll show you something else. So if I say console log effect being rerun, now you can see it's being rerun both times. Now, let's create another signal message. So create signal. The message is, you're not so young anymore. Right. So now if I say if age dot get value, and you might be thinking that now we have two reactions in here, which is a bit awkward, but I don't want to deal with that right now. I mean, we could make this into a set. Go on then, let's make it into a set. Yeah, let's do that. So new set, now we're going to put add, and this, I think this should work actually. I think yeah, there we go. Okay. So just for anyone that doesn't know, a set is basically can only have unique values. So it doesn't, you don't have to look to see if something's already in an array and then not push it if it is. In any case, so we're going to say if age is greater than 30, we say, oh, let's just put 35. Then we're going to say console.log message.get value. Okay. Now, 31. Okay, it's a bit. I wish I could just rerun this without. All right, well, we started here, so this is what we're looking at right now. Or is it? No, it's this one. Can I just do a space and have it recompile? Oh, is there a button down here? I can't see it because my face is in the way. There's probably like a rerun button. Anyway, oh, what's going on now? There you go. Okay, I'm learning about how this this little thing works. Okay, effect is being rerun 31, which is expected, right? Now here's the question. What's our effect reactive to? Well, if you look from a compiler standpoint, you could say, well, you've got the message here, and you've got the age here and the age there. So surely this would be reactive to age and message both, right? Not true, because we didn't actually get here. And so because we never got the message value, we never registered this as a reaction to the message. So if I were to change the message, if I say message.setValue hello, you'll see it's okay. This is just keeping the old history there. Let me just put another exclamation mark. There we go. So you can see it's not being run. Well, it's being run once, but then when I'm changing message, it's not being run again. Why? Well, yeah, because we didn't get to this block here, and so we didn't register this effect as a reaction to message. Now, you might be thinking like, oh, that's kind of dumb that signals aren't reactive to everything in them. But actually, the truth is, for pretty much every circumstance, you won't want it to be reactive to something that it can't actually reach. So the things that are blocking it from reaching a certain um, block of code, you wouldn't care if it's reactive to those things, because without this being satisfied, you would never reach here anyway. So you'd be rerunning it for no reason. And so it's basically only reactive to the parts of the function, or it's only reactive to the signals that are actually involved in the function. You know what I mean? I'm not really explaining that really well. But it doesn't really matter most of the time, almost all the time. It doesn't really matter that this effect isn't reactive to this. It would matter if you're over 35, right? But if you're over 35, the function would have reached that code, and so it would have been reactive to message, right? So let's do that. Let's say, let's say here, you're really over 35. Actually, I'll do this first. I'll say age.setValue, and then I'll put 45. Let me clear it. Let me add a little exclamation mark there. Okay, what's going to happen now? So the effect is run the first time. It gets to 31. And then it's not reactive to the message. But then when we change it to 45, it runs again, right? Because it's reactive to the age. And then the age now that's over 45, when it runs, it gets to get value for message. And now it's reactive to message. So now it's registered. So now when I change the message, now the effect is rerun. You see, and part of the real beauty of this, like what it unlocks, is this idea of nested reactivity. So essentially what that means is like, I could have a function, get message, and it would return message.getValue. And then I could put in here, get message, and clear that. And as you can see, it still works. It's still reactive. See, in the compile time reactivity, you would have seen this. It wouldn't have seen this particular variable. But it doesn't matter how many layers deep of nested reactivity you go, because the moment that you even call that value, like the instant that you call that value, it's recorded in the context, because you're running that function in that bubble of I'm recording all of the times that the bubble of signal recording, basically, signal reaction recording. So that's basically, that's the gist of signals. Now, it does get a bit more nuanced. You know, in Svelte 5, there's different types of runes. They've got like a different personality, but this is the fundamental underlying idea of Svelte 5 and runes and signals. Now, yeah, let's actually go. Let's build some Svelte 5 preview here. Right. So if I say, for example, let x equals 5. Let's do this again. Let y equals x plus 3. Then we go button on click. That's a bit different now. You don't want to put the colons on the on clicks anymore, because now they're more like, or for events, because now they're more like arguments. So I put on click and then increment, and okay, and we put y. Doesn't work. Why is that? So let's look at the JS output. So actually the output of Svelte 5 runes is way easier to read. And as you can see here, what's happening is there's this function called get. So, okay, let's actually, so mutable source. So behind the scenes, Svelte is saying, this is a mutable source of 5. And it's kind of, now, so let me just make sure I'm saying the right thing. No, okay, this have to be state then. Yeah, okay, so there might have been some reactivity things with that, but it might have gone down an unnecessary tangent. So let's just stick with this for now. So we see here that when we say state 5, where this compiler is basically creating a rune out of that, well, a signal rather, with a value of 5. And then the derived rune, you get x plus, well, then there's this get. So the get is the same as like get value in the signal. So when get is called on x, it's saying, okay, here's this function, so you could see this will function, right? That's kind of like the equivalent of our effect that we are programming. It gets this function, and then that function gets stored, and it gets called, and when it gets x, then x becomes a reactive dependency. And so that's basically what creates, what generates y. And then y is a signal in itself, of course. And so you basically get this incrementing thing. Now, this is different than the let's say, yeah, Svelte 4 non-runes, the compile time reactivity, because you can have that nested. You can do nested things. So let's say I said this. Let's say I had a function. A function said function 3 times x, right? And then return x times 3. And then this is x plus 3. So, oh, oops, of course, I gotta call it 3 times x. And as you can see, it's multiplying by 3 and then adding 3. And the reason why this works is because inside of here, it's creating that effect context. And then when it calls 3 times x, it's still within that effect context. And then when it gets x, x is a signal. So it says, oh, where am I being called from? Oh, I'm being called from this context, which is this derived over here. And so it knows to, when it changes, to kind of propagate that. Now with Svelte, with Svelte 5, you can do all sorts of interesting things, like, for example, you can write inside the, if you write a svelte.js file, so it's like animal.svelte.js, or I don't know, car maintenance. Let's just do that, car.svelte.js. So if I create a car class, class car, and then I say fuel number. Oh, TypeScript again. Let's say fuel equals state. Let's say it starts empty. Now, what's going on in here? So let's go JS output. So what you see here is that this is being replaced by getters and setters. So we have a private variable fuel, and then there's the get fuel and the set fuel. So we use this just like we would a normal class, but behind the scenes, these are being wrapped as signals. So let's just like import our car here. Import car from car.svelte.js. I think, is that right? We should do car. Anyway, and then we'll say my car equals new car. And why don't we do this? We can do something like this. Let's put a function refuel, and then we're going to say fuel equals 100, and then drive some distance, right? Distance, and then fuel equals fuel minus distance. Easy. It's okay. So we have a new car, and then we're going to have a refuel button. Let's go to result. and then we're going to have my car dot fuel. Okay, refuel. Oh, that didn't work. That's because we didn't actually my car dot refuel. Also didn't work. Oh, this dot fuel, right? This dot fuel, this dot fuel, thus this dot fuel. There we go. Right. So when we refuel it, and then let's drive some amount, drive there, 20. Refuel, drive. So you can see here, you can create these kind of components outside of the, not components, you can create classes and other sorts of data structures that are reactive outside of components and reuse them in components. And this is nicer, than, it's nicer than the alternative of like having these subscribers set up and then manually calling subscribers, manually calling unsubscribers. I've been doing that for 3 years. I've become really good at doing subscriber stuff, but this simplifies things a lot. Now, there are you have to think differently with runes. You can't just, it's not a one-to-one translation with subscribers. You have to actually think about values. You're not thinking about like connecting functions to each other and having things call other things. You're thinking, well, what is the value that this should end up being? And then you're working backwards from that. So, for example, should refuel. Derived a fuel less than 50. Okay. Should I refuel? Refuel my car dot. Should refuel? Is that? Yeah, should refuel. My car dot should refuel. Fuel is not defined, right? Of course it's not. This not fuel, right? So refuel. So now I'm driving. I should refuel. And like, if we were to do this with subscribers, you could create a derived store and stuff like that, and that would work. But this just makes it a lot simpler, and it's a lot. You have these primitives, these runes that are primitives, and you sort of build them together, and you're not really thinking about subscribing, non-subscribing. Like, you kind of have to forget about that a little bit. You're just thinking of, what do I need? What values do I need to supply in the end? And what do those values depend on? And then you build your chain of runes accordingly. So you're not thinking, okay, when this changes, it should trigger that store, and that store will change this data, and that should trigger that store, which would change that data. You're not thinking in terms of this changing that. You're thinking of, where does this value come from? And you're working backwards. So it comes from this derived value, which depends on this, which depends on that, which depends on that, which depends on that. And that's kind of how you set up more complex rune type environments, or data structures or whatever. Anyway, this video has gone on long enough, so yeah, I hope this is useful. Let me know in the comments if you have any questions or anything of the sort. I'll be happy to make another video. There's more to runes than this, but I think this is sort of like, if you get this, if you kind of get the idea, like every component is wrapped in like an effect root. And so all these changes are happening within this component, exist within this root. And the signals are just remembering when they've been called to trigger those derived things or the effects or whatever. If you think like that, you'll be able to build some really cool stuff. Actually, before I do that, let's just peek in here again. So we went over the fuel thing. Set. So when get is called, it's doing the same thing as get value. So it's recording the effect context. Set is the same thing as set value, which is basically that we made in our vanilla version, which basically sets the context, or sets the variable and calls all of the effects that have been stored for that one. Should refuel now is a getter, and it gets it. It gets the derived store, and that derived store. It gets the derived rune, which is a signal, right? And again, it records all of the different effects that are calling it, right? It's no different than this, getting the fuel. Now you're just getting the should refuel. Um, and the rest is just the same. Like, when you have something like this dot fuel, it's calling the setter. This dot fuel here is getting this. And so this function is just sort of like it just encapsulates this. But the reactivity stays inside, because the moment that you set fuel or that you get fuel, all of the reactive links are created during that period. That's why it's called runtime reactivity. Anyway, I hope you enjoyed this video. Yeah, let me know in the comments if you have any questions. And there's more to runes than this. Yeah, definitely. But this is, I think, if you get this, it's a good foundation to have.